Okay, what are you going to do with the expression g of h of x? Two things you can do with it, okay? Like, what is h of x?
1 over x.
Well, then I could substitute 1 over x for h of x, right? I mean, that's exactly what you're supposed to do with a composite, right? Now, there's another way you can do it. You can use the definition of h of x to do this, right? You could use the definition of g of x to do what? If g of x equals x cubed, what's g of h of x? If you replace this x with h of x, then you got to replace this x with h of x. If you replace this x with h of x, what do you get?
1 over x cubed?
I'm sorry?
1 over x cubed?
Yeah, but let's do it one step at a time. That's where you end up, and that's really good. Okay? You can, to avoid confusion, we don't, you know, we do the simplest possible thing we can do. Okay? Now, there are two choices for the simplest possible thing. H of x is 1 over x, so we see h of x, you can write 1 over x. Okay? Or you can use this definition and replace x with h of x, right? So you could write this as h of x cubed. Okay? Because that's what the g of x function does. If you replace x by h of x, then this becomes this, and this has to become this. Okay? So you're trying to do too much if you do any more than that. Just the simplest, most obvious thing. Replace x by h of x. Okay? Or replace h of x by 1 over x. You can do that either way. Okay? Now, what's g of 1 over x? Well, how do you do g of 1 over x? You go back to the definition of g of x and see that 1 over x is replacing x, right? So you replace this x with the 1 over x. Okay? Now over here, you're going to replace h of x by 1 over x. Look at that, you get exactly the same thing, right? Which shows you could do it either way. You can look at it either way. Now, what I'm going to ask you to do for homework is look at it both ways. And I'm going to ask you to do composites of pretty much every basic function with just pretty much every other. Okay? And then we're going to get a whole new set of functions, the inverse functions. Okay? And then we have pretty much a complete set of basic functions. Inverse function is going to be regarded as basic. Okay? Now I want to come back to this table here, and I don't want to take time to write it out again. We only have a couple of minutes, and I don't want to keep you over. Not that I'm anxious to get rid of you. You're great to have, but you got places to go. Okay? Now, you notice that here we have two possible paths for this process, right? Okay? Because I could have taken this one here could have taken the 4 and fed it in over here, right? Okay, and I would have then ended up with the 2 I started with. So I could end up with what I started with, but I don't have to. Now that's related to some properties of the graph that you get when you graph it, and we'll pick that up after you've graphed everything, which you will do for next time, right? Okay? If you get it wrong, okay, we'll address it, but try to get it right. You learn more that way. Okay? Now, is it possible to do that up here? Is it possible to take 2 different paths? Starting with the 1/2 here. Now the path is, we got to go directly over to from the x value to the y value, but then we take that y value and we feed it in as the x value, right? Okay, is there any place else I could have gone with that 1/8? Well, 1/8 only appears once here. Well, the problem down here is that 4 appears twice and gives me 2 different results with the inverse relation, okay? Of course, the inverse relation here isn't a function, is it? I mean, what do you get if x equals 4? On this table, you get 2 different answers. That's not a function. It's a relation. It's not a function. Okay? So we have an inverse relation, but we don't have an inverse function. We'll see what to do with that after you've done the graphs, and see how the graph shows you don't have a function. Okay? Up here, your inverse relation is a function. Okay? There's no number here that appears more than once. So we take any number here, there's only one way to find out the one. Okay? So this inverse relation is a function, this inverse relation isn't. So I'm just going to make a note here, important idea. This inverse relation is a function, this is not a function. You might want to review what the definition of a function is. Okay? I'm going to ask you to read some stuff in your packet. Now, it's between Tuesday and Thursday, so I'm not going to ask you to read more than 200-300 pages of it. Okay? But I want you to scan it. And I've already told you to scan what I've done. I hope you've done it. Because if you have, you're starting to develop a better picture of what we're trying to develop a picture of. If you haven't, it's well past time to scan it. Okay? Carve out at least 15 minutes to scan what you see and see how much of it you recognize. Okay? And if you scanned it before, scan it again. You probably recognize more than you did because we've done stuff since then. Okay? Be sure you do those things.